Now that we've got two variables, now we can solve a system of equations. And so the first thing we're going to look at is solving systems of equations with two variables. That means two equations. And we're going to look at this from using two different ways to do it. And what you have when you have that, remember your x and y means that you have an xy coordinate plane. And when those two lines intersect, they intersect at a point. So your answer when you're done is an ordered pair, which is the point at which those two lines intersect. So let's look at this. First of all, we're going to look at two equations, and we're going to check to see if those ordered pairs actually are a solution to this equation, to this set of equations. So if I have x plus y equals 10 and x minus y equals 0. And my ordered pair is 5, 5. What does that mean? It means I have to substitute 5 in for the x and 5 in for the y in each equation and see if it makes it true. So 5 plus 5 equals 10. Yes, 10 equals 10. So this one, that ordered pair is a solution for that one. But what about this one? 5 minus 5, does that equal 0? Yes, 0 equals 0. So yes, it is also a solution for this one. So this ordered pair is a solution for this system of equations. Okay? So that's what it is. We can look at it from an ordered pair, substitute it into each of the equations, and find out if it produces true statements. Again, using those same principles that you've already learned, how to substitute an ordered pairing into your x and your y, and find out if it's true or false. So it's a good thing to know how to do that, because you can use it again. So, next thing that you're going to see in your lesson is you're going to see a graph with two intersecting lines on it. And you're going to have to identify which one of those ordered pairs that I give you is a potential solution to this. Well, first of all, remember the quadrants. Quadrant 1, your ordered pairs are positive, positive. Quadrant 2, negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So, when you're looking at the ordered pairs, you're going to look for one that has a positive x and a negative y. So now let's look at our choices of ordered pairs. We have 6, 4, 6, negative 4, negative 6, negative 4, and negative 6, 4. As you can see, this one is in quadrant 1. Well, my intersection is not in quadrant 1. This one is quadrant 4. Well, my intersection is in quadrant 4, so therefore, that is probably it. But let's look at this. Negative, negative. This one is quadrant 3. And negative, positive is quadrant 2. So you see, it may not be the most accurate drawing of it, but this is the only potential ordered pair that will answer that, because it's in only one that is in quadrant 4. So these kind of things you will just use intuition and what you know to what it is, okay? So now we're going to look at solving these equations. Sometimes if you draw a graph, if the intersection is precisely on the lines of graph paper, you can tell what it is. But a lot of times the solution are not integers. And if they're not integers and you try to graph to find it, it's not going to be accurate. It's going to be guesswork. So we're not going to do it by that way. We're going to do it by algebra, okay? And we have two different ways that we're going to do that. Okay, first of all, we have two possibilities. The system either has a solution or we can have a system. When it has a solution, you're going to get an XY ordered pair, okay? Your system can be inconsistent. When your system is inconsistent, what you actually have are two parallel lines, which means they do not intersect and will never intersect, okay? So this one has no solution because parallel lines do not intersect. Or your system can be dependent. What happens with a dependent system? A dependent system is one line on top of another line. And in this case, when your lines are on top of each other, what happens? Now you have infinitely many solutions. It's not all real numbers, but it is infinitely many solutions, okay? So these are the three kinds of solutions you will see to these. Either a solution with an XY ordered pair, an inconsistent system which has no solution because it produces parallel lines, or a system can be dependent, which means one line lies on top of the other line, okay? So let's look at some of these. Here I have 2x plus 3y equals 6, and 4x plus 6y equals 12. If we're to graph the x and y intercept on this, we'd have 0, 2, and 3, 0 on the first one. On the second order pair, you'd also have 0, 2, and you would have 3, 0. These two equations are exactly the same. What happened? I simply multiplied my first equation by 2, and that means this system is a dependent system. The two equations are on top of each other, and it's infinitely many solutions. Okay, so now let's find out what happens with another kind of equation. And again, if I were to graph those, what would happen? Well, I have 0, 2, 3, 0. There's the first line. The second line also has 0, 2, and 3, 0. And there's my second line on top of it. Didn't get it drawn very well, but the two lines are on top of each other. All right? So that is your dependent solution, infinitely many. We'll do the other kind when we run into it. So how do we solve a system of equations? We have two different methods. The first method we use to solve these is using a method called substitution. Okay, so let's look at that method first. Well, actually, we have three methods of solving these. Three methods. The first method we already talked about is graphing. And we talked about the problems with graphing. The second method is through substitution. And the third method is through elimination. So, as you can tell from the word substitution, you're going to substitute something in for something, right? Because that's what that means, is to substitute. So when would you use substitution? Substitution is usually used when there is an x variable or a y variable with a coefficient of 1 in one of the equations. If that is the case, you solve for that variable and then substitute the expression, the resulting expression, into that same variable in the other equation. Then use equation solving skills to find the value for that equation. For that variable. Let's use the word variable instead. Okay, once you've done that, then use that value and substitute it into the first equation. Solve, or actually calculate, because that's what you usually end up with, okay? And that will give you both of your variables. So, let's look at two equations and go through that process. So we have our first set of two equations, 2x minus 4y equals 12, and I have x equals 4y. Well, this one is already, my x has a coefficient of 1, and it's already equal to 4y. So that means I can take this 4y, substitute it in for the x in this equation, and end up with 2 times 4y minus 4y is equal to 12. 2 times 4y is 8y minus 4y is equal to 12 because 2 times 4 is 8. 8y minus 4y is 4y equal to 12. Again, divide by 4. See, this is just equation solving skills. And now you have y is equal to 3. That means that's the y value in my ordered pair. Now, I'm going to go back to the equation I used as my substitute, this one here, and I'm going to put my 3 in for my y. So x is equal to 4 times 3, which gives me x is equal to 12. So my ordered pair solution is 12, 3. Okay? You're going to end up with 2 different numbers, one for your x and one for your y. Let's look at another example. 3x plus 2y is equal to 6, and 4x plus y is equal to 3. Notice, this equation here has one of my variables with a coefficient of 1, so I'm going to solve for that one, which means I'm going to subtract 4x from both sides, and I'm going to end up with y is equal to 3 minus 4x. This is the equation that I'm now going to use to substitute this expression in for the y in my other equation, okay? So you have 3x plus 2 times, my y is 3 minus 4x, and that's equal to 6. The only thing you change is you take this expression for the y and put it in for that y up there. So now I'm going to use equation solving skills, and I'm going to solve this thing. 3x minus 8x is a negative 5x plus 6 equals 6. Continue solving your equation by subtracting 6 from both sides, so negative 5x is equal to 0. Divide by your negative 5. So x is equal to 0. That is one of the values for the ordered pair that we need. Okay? So now we're going to substitute that 0 in for my x right here. So y is equal to 3 minus 4 times 0. 3 minus 0 gives you 3. So y is equal to 3. My ordered pair is 0, 3. That is the point that is common for both of these equations. And remember, we can always plug it back into the equations and check it out. So 3 times 0 plus 2 times 3. Does that equal 6? Well, this is 0. 6 equals 6. Yes, that checks. Look at my next one. 4 times 0 plus 3. Does that equal 3? Yeah, it does. Because this is 0, so this is 3 is equal to 3. It checks out. So we know for sure that that ordered pair is the solution for both of these equations. Okay, so now let's look at the elimination method. And some of the problems, you could actually use both methods on them. So a lot of times it's your preference as to which method you really want to use, since they're not necessarily totally exclusive. So let's look at elimination. Elimination method uses multiplication by integers to arrive at either the same coefficient for one variable or opposite coefficients. prefer opposite coefficients. And the reason I prefer opposite coefficients is because if you have opposite coefficients, you can simply add your equations. If they're the same coefficient, then of course you would have to subtract. And a lot of you make more mistakes in subtraction than you do in addition, which is why I prefer opposite coefficients. Okay? Once you have those opposite coefficients, you add the two equations. And one variable will be eliminated. Which is why this is called the process of elimination. Okay? Solve for the remaining variable. Then substitute that value into one of the two equations. Now solve that equation for the second value. And remember, just like in the first one, you can always check it. Okay? So now let's look at an example. Negative 2x plus 3y equals negative 16, and 2x minus 5y equals 24. Notice I have the same coefficient in front of the x, except they're opposite signs. So if I add these two equations together, this is going to cancel out and end up being 0. Negative 2x plus 2x is 0. 3y minus 5y gives you a negative 2y, and it's equal to negative 16 plus 24 is a positive 8. Okay? Now, divide by negative 2, because we're solving now for our y. Y is equal to negative 4. That's one of your values. Choose one of these two equations, and let's put it back in and find the other one. Let's choose this one. So 2x minus 5 times negative 4 is equal to 24. 2x plus 20 is equal to 24. Minus 20, so 2x is equal to 4, and divide by 2, so x is equal to 2. There's your other value. So your ordered pair is 2, negative 4. Now, if we want to find out if that's really true, go back to this equation and let's plug it in. Negative 2 times 2 plus 3 times negative 4, does that equal negative 16? Well, this is negative 4 minus 12. Does that equal a negative 16? Well, negative 4 minus 12 is a negative 16. It does. So we checked it, and we know we have the correct answer. Okay? So there's one. And we didn't have to do any work on that one to bring our coefficient to the same number, as you can see. Our negative 2 and our 2 were already the opposites of each other, so it was a perfect elimination problem. So now let's look at some others that are not that simple. Oof. Let's stop that one and start another one because it's a long one.